Welcome back to another Trailmakers tutorial with Fenrir. Today we're going to be going over logic and how it can be used for control and selection systems. They can be used to do all sorts of cool things, like this bounce test for Pong. Now I do have the full game of Pong, and I might use that as an example later, but we're going to start small, and we're actually going to start very small, so feel free to skip a few minutes ahead if you already know a little bit about logic, because these first two are pretty basic circuits. Now this one here, I set up some pipes to help show the connections for the very newbies, but the pipes will help out in some of the more complicated ones over there. So what's happening here is if you press X when you spawn in, it'll be turning on the green light, but if you press R1, it switches over to turning on the blue light with X. And you can see the lights on our logic switching over, which I probably could have done an indicator for which side is currently active, but never mind that. Let's just get through this one real quick because it's simple. We have our primary line in pink, which is what our actual function button is. So like if we were using this to fire two different weapons, X would be perfect for it. And that just links into a green AND gate and a blue AND gate. Then there's also a NOR gate, which feeds into the green AND gate. And we have an OR gate, which has R1 on a toggle, and that feeds into the NOR gate and the blue AND gate. So simple enough. The NOR gate starts off in an on position, so that allows this AND gate to be activated by X. And then when you press R1, it turns on this OR gate, which turns off the NOR gate and disables the green, but enables the blue. So very simple, very basic. Let's move on. Almost even simpler is button combinations. So here we have, if we hold down R1, does nothing. If we hold down L1, does nothing. If we hold down L1 and R1, it lights up the blue lights. And if we hold down those two buttons and press X, then it holds the green light on. So this is just for if you need a couple more functions and you don't have enough room on your controller for them, you can start doing button combinations to kind of break it up. And you start off, well actually you would start off with the AND gate with one of your controls, and then you would put an OR gate feeding into it with the other control. And the same thing if you have more than two, you would start off with the AND gate and one of your controls, then attach OR gates into that AND gate with the rest of the controls. Again, very simple. So now we can move on to something a little bit more complicated, a little bit more reasonable to need the pipes, because we have a multi-toggle. These are both multi-toggles here, the big one and the small one, but this one is what I call looping multi-toggle. And what that is, if we look at the little lights, is once it reaches the end, it restarts, as if it loops back to the beginning in a full circle. So this one particular demonstration is a 4-stage one, but you can expand them to as big as you need. So in a similar fashion to the earlier pipes, we have pink as our primary with X, and that's the only control on this build. It just switches which line is active, and with other circuits that you already saw, you can then do things from there to make it more complicated, or just route them directly into functionality if you need. But anyways, the circuit itself, right. So we have a couple things going on here. The first time you press X, it's going to activate this AND gate here in blue because our capacitor here starts, or I called that a capacitor, our accumulator here starts off with no charge. It has a minimum of 0, a maximum of 3, and it's set to use steps. So when you spawn in the build, there's nothing in it, so it's setting off a signal of 0. And if it's setting off a signal of 0, this comparison gate, out of these 4 comparison gates linked up to it, as you can see by the green pipe, this first one here registers the threshold of 0, the second one a threshold of 1, the third a threshold of 2, and the last one in yellow a threshold of 3. So like I said, when we start off, the accumulator has 0 charge, which trips this comparison gate, and any of these blue comparison gates feed into one OR gate to consolidate the signal, and then the OR gate feeds into the AND gate. So the first time you press X, it'll, well, and I should show that the AND gate sends a positive signal to the accumulator. So the first time you press X, it activates with this comparison logic, routes down to here, to the AND gate, then clicks up the accumulator by 1 notch. Then the same thing happens the second time and the third time, more or less, just moving over which comparison gate's active. Then finally, once we hit a full charge of 3, and press X again, which, yeah, the primary line here you can see feeds all the way around into the yellow. But instead of going directly into the accumulator, this negative signal from the yellow first goes into our arithmetic gate, because in order to reset the accumulator fully, we need to send it a signal of 3, well, -3, instead of just a signal of 1. Because it's in use steps, it'll go all in one burst. It doesn't have to take time to shrink the value back down. But what we do need is to use the arithmetic gate to multiply it. So we multiply it by 3, and then we send that into the blue and yellow pipe, which goes to the accumulator. So that's the looping toggle, which is the simpler one. As you can see by the spaghetti mess to our right, it gets a little bit more complicated from here. So I decided to pull out the non-pipe version of this circuit as well, just in case the pipe version is a little too messy to follow. But what this is a bouncing multi-toggle, and that just means that when it reaches the end, instead of going back to all the way to the beginning automatically, it bounces in the other direction. So it goes 1, 2, 3, 4, 3, 2, 1, instead of 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And an application for this that I recently used was to make Pong. This is just the ball bounce test, but it uses one of these circuits in each axis, and then it's just being run by a little clock over in the corner that clicks it on and off. So it advances the ball one direction, then once it hits the wall, or the end of the accumulator, it switches the direction that it starts clicking in, and it clicks it the other way. So let's pull up in build mode and start talking about it. So we'll start off with the similarities to the previous circuit. We have pink as our primary, but we also have a NOR gate attached to it, so that we can check when we're not pressing X. We have green for our accumulator and comparisons. And again, it's set to minimum of 0, maximum of 3. Then we have the blue line, which is for increasing our accumulator. And we have the yellow line, which is for decreasing our accumulator, which bounces it back the other way. So the first time we press X, we have this first comparison gate on, because the accumulator is 0. And if it's any of these 3 comparison gates, it feeds into our light blue line here with our consolidating OR gate, which just then goes down to our AND gate here. We have a check to see if we're pressing the button, if we're pressing X, and we also check to see that this NOR gate is on. The NOR gate gets turned off if we have, what do we have here? Yeah, this is what I was worried about. This pipe mess is starting to confuse me. Let's switch over to talking about it on this side and see if this helps at all. The only difference here, and I probably could have switched it before recording this, but oh well, is the accumulators in yellow and the other switchers in green. But it does the same thing. It bounces the signal back and forth. And visualizing it the way that I have these laid out here might help a little bit more too. So let's go through it on this one. So on X, we already got through it. We got through what happens here, consolidates the signal, sends the signal to this AND gate, not that one, sends it to this one. Now, okay, here we are. We're checking the NOR gate here. So if we're advancing from left to right, this NOR gate will be on. And if we're advancing from right to left, this NOR gate will be off. That's where the green line is coming into the blue line here. Well, one of the places. Again, it's spaghetti over there. But yeah, the same thing happens for this comparison gate and this comparison gate. It's not until the last one on the right here something different happens. Now this one feeds into both an OR gate that has all 3 of these, which is just for the it's for the reversing, so we can ignore that for the moment. The switching is on this one here, this AND gate. So when we're at our last comparison gate and we're not pressing X and we haven't currently flipped to the other direction yet, only then does it toggle this OR gate, which switches the direction, the flow, I call it. It switches which direction the signal starts traveling. And then from there, it starts to feel a little bit more simple again, because this links into the AND gate that switches signal. It sends a negative output to the accumulator every time you press X, assuming that this OR gate has been toggled on. And I'm honestly not sure if I covered everything in this circuit or not, but hopefully I covered enough that you can figure out any missing pieces for yourself. Let's see here. Can I think of anything that I missed about this circuit? But if that has you still scratching your head, we can go a little bit simpler while still being more complicated, and I've just been recording for a while. The build has disappeared. Anyways, let me pull it back up because we have some more that we can check out. We have, where is it? The selection panel logic. Which can give you plenty of options while being a lot more straightforward to set up. So this one just has a basic 2-button toggle. So press one button to go right, one button to go left. That way you can change on the fly which one you're selecting. If you press X, it lights up the first light below it. If you press anything on the D-pad, it lights up other lights below it. So what's happening here is we have our primary here as the accumulator in pink with L1 and R1. And that is switching which one of these comparison gates is on, obviously, but switching which one of these lights at the top is on, as these comparison gates link directly into them. And that activates the entire row of AND gates below it, or column of AND gates below it. And the same thing for each of these other colors. And you can see the little pipe nuggets that feed down into it. Then on the left side, we have our control inputs. So X, and then all our D-pad controls. And they feed into each row across. So any of these AND gates can only be active if it's first selected in that column by the accumulator, and then it checks if the button is being pressed. Much simpler, and can give you a lot of options. This panel here has 20 options, and can be set up in just like a few minutes easy. But I suppose now, if I have any remaining time in the video, I'll pull out some examples to show off some uses of these logics. So for this example, this tank uses 2 circuits that we've shown. One of the earlier very simple ones that just toggles between 2 possible states, and then the selection panel from over here. Because we just have 2 different selections. We have turret A and turret B, and it has 5 controls for each, of course. We have the D-pad and X for firing. The machine guns all fire at once, they're not included in the selection. Then when you press R1, it toggles to the other turret. And that way you can have separate controls for different turrets in your vehicle. And it does make it a little bit slower to control the vehicle as a whole, instead of having them under this, like 2 turrets under the same control. One of the upsides is you can have different rotation speeds and such for it. Like the bigger main caliber here has a slower rotation than the little front caliber. So this plane has a couple of different logic systems in it, but the one that I'm showing off as an example for is its adjustable fire rate. So when it spawns in, you can see there's some red lights on, and that means that it's in full fire mode. All 3 pairs of smart cannons will be firing. If we press right on the D-pad 1 time, we switch to medium fire mode, and only 2 are active. And if we press it 1 more time and go to the blue, only a single pair of smart cannons are active. So this way I can adjust how my fire output is in the middle of a fight without having to actually stop and take guns off or add guns, letting me fight multiple opponents and be fair to each of them at the same time. A couple other circuits in this plane are, we have a little AND gate system combo circuit in the back, where if you press R1 and L1 at the same time, it spreads the tail open, which normally, if you had the controls set up the way that I do on here, and pressed them at the same time, it would just return them to a neutral position. With a little bit of logic, it spreads them out instead and acts as a rudimentary air brake. And then the final thing that's in here is it has a high and low maneuvering mode. And what that is the pink light that I'm clicking on and off right now. And when the pink light is on, all of our controls are limited by 50%. So it's a low maneuvering mode that helps for fine control in flight. And anytime we need tight turns, we can go back to full maneuvering. And you can see when I'm doing that, every time it's automatically clicking the angle of the servos up 50% because I'm just holding the control. And I think that's all the logic in this plane. So let's try to pull out one more example. So for the final example, and a reward to anyone who lasted to the end of the video, whether you skipped here or not, we have Flappy Bird, which is my newest game that I finished creating. Well, not creating, recreating. But let's go into the top to seat camera for the best view. And let's go this way so the light's not glaring on us too badly. It's pretty simple. If you press or hold X, our little bird goes up and down. When you press R1, you'll start the game, and then almost immediately I'll mute the music, because you can mute the music and the bird independently. But as you can see, it starts putting the walls out. The walls are randomly generated in their the height of their opening. But the opening is always consistent. And just like good old Flappy Bird, you just have to fly through the holes in the wall. I'm going to purposely hit the next wall to show you that the game automatically resets, though it does take a little bit. There you go. And it holds the score. I got 6 walls, and it holds the score only until you restart by pressing R1 again. And I'm going to mute the music, because I probably have my own music going in the video and had to figure that out later. But yeah, with the right logic circuits and enough patience, you can make just about anything in Trailmakers. The real difficulty lies in that 700 complexity limit. If I want to make more complicated games than this, I might have to start making multi-part builds of them, which could be fun, but could be very challenging too. We'll have to see. But I think that about does it for this video. If you liked what you saw, leave a like. If you have any questions, leave a comment. And if you want to support the channel, subscribe. It's YouTube, you know all that. Bye-bye now.
PlayStation